All right, hey guys, how's it going? All right, so I made a few adjustments to my setup here. So just if you think the audio or video is a little bit better, just let me know. But yeah, we're gonna get started. This is part 2 of 2 for the motherboard that we're working on. So I got the motherboard right here on the heating rack. I have a different lens on the camera, so I can zoom it in a little further. The lens that I was using, it was only a 14 to 42, so it couldn't reach as far in, couldn't zoom as far. This is a 45 to 140. So anyway, so you can see it a little bit better. It's a little bit closer to the board, so it's going to be a little easier to see. But yeah, so what we're going to do is we're going to go ahead and install our socket that we have today. If you didn't see the last video, this is a LOTES, L-O-T-E-S socket that I bought off AliExpress. It cost me about $7, probably like $8 with shipping. I got 2 of them just in case I mess one up. I don't even know how many pads this motherboard has. So this is the AM5 platform. There's probably like 1,500 balls and pads on the bottom of the socket here. So we're gonna have to do a really good job lining this up, because you can see how tightly packed these are. I mean, they're right next to each other, and you can see on the pads too. So we can't have a single one of these bridged. So what I'm doing right now is I'm preheating the board. I have the board on my heater. I'm going to go ahead and glove up real quick, and we're going to start putting some flux on top of the board, and then we'll get set up with our jig and everything. We'll get set up to begin the reballing process. So no guarantees that this is successful. This is just an attempt for me. I did try this one other time with an AM4 socket. Now that used unleaded solder. It was a massive pain in the butt. My tools are like just barely capable of removing a socket or a chip or whatever of this size. So we're gonna give it a shot. We're gonna see what we can do. I might even have to remove those washers, because I think that presented an issue in the first video. So anyway, without further ado, we're gonna glove up and get started. Okay, so first things first, I'm gonna go ahead and check the temperature of the board. I've had it on the preheater for about, I don't know, maybe 5 or 6 minutes. I just want to check the temperature real quick with the thermal camera before we go any further, just to see kind of where we're at as far as the temperature goes. I want to see how much heat we're getting into the board. Also, I have my hot plate set to 300 degrees right now, so just to let you guys know. Again, if you guys are interested in picking up a thermal camera, this is the cheapest thermal camera that I could find anywhere. AliExpress, eBay, Amazon, whatever. I don't know if it's still the same price. Actually, let me check real quick. I'm just going to check and see how much it is. Give me 1 second. Okay, so I just checked on Amazon. It's gone up to $129, so it's $10 more expensive, but it is still the cheapest thermal camera that is 256 by 192 resolution. So definitely, if you're into electronics repair, or you're considering getting into this hobby or field or whatever, this is definitely a really good tool to have. You really need a thermal camera. I would say more than you would need, like if you're doing repair, you would need a thermal camera more than a oscilloscope. It's just as important as a multimeter, in my opinion, when it comes to troubleshooting any kind of components, circuit boards, whatever, because 99.9% of the time it'll be like a shorted component, and if it has a short in it and you inject voltage into whatever the circuit is, it's going to heat up, and if it heats up, you can see it with a thermal camera. Now there are other ways around it. You can use, there's like they have rosin pens, or like flux pens. It's basically like a vape pen for your board, and what it does is it deposits a thin layer of flux over whatever it is that you hover it over, and when you apply electricity into that short circuit and the component heats up, it'll melt the layer of flux, and you can see it visibly. If you want to be even cheaper than that, you can go the route of just using alcohol. So you can put alcohol on the board or on the chip that you suspect to be short circuit, and put electricity into it, and the heat will evaporate the alcohol. But when it comes to certain short circuits, like for example, you don't want to put any more than like a volt or two into the component or into the board. Sometimes it won't show up. You won't, you can use the flux pen method or whatever, or the resin pen method. You can use the alcohol method, and it's still not going to show up. Even like the little cheap $70 thermal camera that I have, it's not going to show up. You need something that has a very precise scale or representation of temperature, and something that has a decent resolution. That 256 by 192, that really helps a lot. Okay, we're at roughly 80C, so I'm going to go ahead and start putting flux on the socket. Get this ready to go. And we're just going to make little zigzag patterns. Just try to get as much on here as I can. Now, leaded solder melts at 183 degrees Celsius, so we're going to need to use our thermal camera to see once we reach about, I don't know, maybe 190, 193, 200, somewhere around there. Once we reach that, then we know we're good to go, and then we can back off the temperature. So we'll definitely use that to our advantage. Okay, so I just use the tip of my finger to apply the flux, kind of, smooth it around the board a little bit. And then we're going to take our socket and we're going to drop it on here. Now the outline of this Lotes socket doesn't quite match up with the outline of the old socket that was on there. I think it was probably, I forget the name of the brand, Foxconn, that's who it is. I think it's different than the Foxconn. So what I'm going to do, and I might not be able to get it on camera, but I'm going to take a peek from the edge, like from the side. So I'm just going to look underneath it, and I'm going to see if it's lined up that way. Also, I made sure that I had no balls or no pads, like solder on the pads sticking up. So that way I can place the chip. And one thing you can do, so you can place the chip down like this. And once you're in the center, it should grip. So right there, boom, we're locked in the center. And I can actually feel it with my finger. I can feel the socket moving around, and the pads are recessed underneath the solder mask. So the solder mask sits on top of the pads. The pads are just slightly recessed. So as long as every single pad is flat, like completely no solder on it, you can put whatever your component, chip, whatever, and you can lock it down on the board. And if you see, I can take my finger and I'm wiggling it around, and the socket is moving, but it's staying in its place. So all those balls are pushed down into the pads, and then the solder mask is kind of like a little cup that is holding the balls inside. So that is pretty good. Just double check. Yeah, I think we're good. So I'm just going to take a peek real quick, because we could also be, so one of the things you need to watch out for, because there's so many rows of pins, we just need to make sure that we're not like one row over. We want to make sure that all the rows are lined up completely, because there is a chance that it could be one row over and still kind of like settle in like that. So we just want to double check and make sure that we're not like overlapped a little bit, but just by looking at the camera here, it looks like we're pretty good. So I'm just going to take a peek underneath real quick, and if everything looks okay, then we'll go ahead and get started. So I'm just trying to focus in here with my microscope so I can get a little better view. But obviously, as you can see, I can't really see anything. I can't see any balls from here. So unfortunately, that's not really going to work. I'm going to have to eyeball it. So, which is not a big deal, but yeah, it's good to get some sort of like visual indication, just to make sure that we're not, not off by one or whatever. You want to be spot on with these kinds of things. So I mean, I trust myself, so I'm pretty sure that we're right where we want to be. But at the same time, you know, just want to make sure. Yeah, there it goes. It just slipped. Yeah, now we're locked back in again. Okay, I think I got it. I think we're good. Okay, yeah, I checked it a few times. It's really hard to see this. If I would do this again, I would try to find the Foxconn socket with leaded solder balls and use that one instead, because it actually will fit the, or it should at least fit the profile of this outline here. This one, it's impossible to see. The edges are rounded. There is a little bit of plastic protruding that should rest on that little inner marking there, that little inner line. So there's two lines. There's like an outline and then an inline. But yeah, I mean, I've moved it around my hands and it sets into that one spot. It keeps wanting to go into that one spot. So I'm just going to leave it there. I'm going to trust my intuition. And now, unfortunately, this is part 2 of 2, but I have nothing that I can use to test this motherboard. So once this socket is installed, unfortunately, we're going to have to wait a couple weeks until I have enough money to buy a processor and RAM, and then we can fully test it. Unless maybe, I don't know, I'll see if AliExpress has a chip tester. I don't think they have one for AM5. I think they just have the pin type for AM4. But you never know, they might have one inline for AM5. And what that does is it just, it's essentially like the outline of a CPU. You drop it in, and it has a bunch of LED lights on it. And so what it does is it checks all the data lines, like in the power lines, and it will light up. And if there's any data or power line that's missing, that light will be out. And so that'll let you know that there's something wrong with your socket. They're plentiful and cheap when it comes to like AM4, but AM5, because it's a totally different type of socket, I don't know if it'll work or not. So just a heads up. All right, so again, just want to exercise safety first. Make sure you have all your protective gear on. I have masks on to prevent flux, you know, from breathing in the flux. Second thing is, and you can kind of see it, it's a little bit blurry and hard to see because it's off screen here, but is the heat gun. I have it rested down on top of the CPU. I just made sure ever so carefully to drop it down. You do not want to disturb this area whatsoever. You don't want to bump the board. You don't want to tap it. No vibrations whatsoever. You do not want to move the socket in any way, because even if it shifts just a fraction of a millimeter, you could end up bridging a connection and the whole thing's failed, and then you have to start over again from scratch. So just to keep that in mind, you want to be super careful, deliberate, slow movements whenever you're doing this kind of thing, because guaranteed you will mess something up, and you just need to be careful. All right, so next thing we're going to do, I'm going to go ahead and turn on my extraction fan, and then once the extraction fan's on, we're going to start turning the hot air gun on. All right, so the extraction's on. Before we turn the hot air gun on, I'm going to go ahead and get my thermal camera ready on the computer here so you guys can watch along and see what I'm looking for as far as temperature goes. All right, guys, we are all set, ready to go. I have my thermal camera set up here, and I got the table set up here. Actually, let me shrink this down real quick first. Okay, that's a lot better. I just want to make sure that you guys are actually able to see the whole board, or at least the whole image of the camera. I had it zoomed in really far, so it was too far. But anyway, here is the thermal image that we're getting. Currently, we're right at about 75. Now it says 85, so probably 85. Yeah, about 85 degrees C on the board. Our nozzle is cold here because we haven't turned that on yet, but you can see, if we pull out, you can see where the heat is concentrated underneath the board. So that is good. I'm going to go ahead and raise the temperature on my hot plate. Actually, I don't know. Yeah, let me just raise it just a little bit because we're at 80. I'm going to try to get the board to like 100 degrees C before I turn the hot air gun on. All right, so I'm going to go ahead and turn my heat gun on. Just going to start the air off kind of low because I don't want to cause too much turbulence for the socket. So go ahead and turn it on. And okay, so it looks like right now I have it set to 300 C. So I'll just leave it at that. And I'm going to put the air at about 4 out of 8. So right now it's at 4 out of 8. And let's go back to the thermal. And we are right almost at 100 degrees. So that's perfect. Yeah, we're like right at 100. So I'm going to let this bake just a little bit. And then I'll get back to you guys as soon as we start approaching 183. So once we start getting towards 183, I will begin recording again. All right, just to give you guys a better look. So we're right up in there. And you can see we're approaching 140 right now. This is the outlet of the vent on the nozzle. And you can see it's in the 150s almost, 150. And closer to the board, we're at about almost 145. So, and then here's a better view from further away. So you can see all the heat concentrated, and you can see how the heat kind of wicks away. So that's what I was saying with these, motherboards. The PCB is so large that it wicks heat away. So the last thing you want are the heat sinks and the VRM heat sinks and any kind of thermal mass on the board, because it's just going to go absorb the heat and dissipate the heat. So the last thing you want is, all that heat wicking away. You want to try to concentrate as much as possible. So, and let's just check on it one more time. All right, so we're approaching 150 C. I still have my heat gun set to 4. And let's check the outlet. So it's like 160, 170. Okay, gonna let this bake a little bit longer, and then I'll get back to you guys here in just a minute. Also, just to let you guys know, I did the hot plate, I did turn it up to its full temperature, so it's at 400 C right now. So just to let you know, it's set to 400 C. All right, so we're starting to reach 183 inside. So this should be the moment that the balls begin to drop. Now, because of the technicality of this process, or how crucial it is to get a good seal between the socket and the motherboard. Normally, whenever you solder like BGA, or you do BGA work or BGA soldering, you want to tap the chip or whatever it is to make sure that the balls have dropped. But in this case, I don't want to disturb the socket, so the last thing I want to do is tap the socket. We're just going to heat it up, let it hit its target, and then once it hits its target, then we'll turn it off and just let it cool back down. And then obviously later on we can test it. If we need to reheat the socket, and reflow the socket, we can do that later. That's not out of the scope of possibility. The last thing we want is to bridge a connection. So we want to be as careful as possible not to bridge a connection. So anyway, let's take one more peek here real quick and we'll see what our temperatures are. All right, we are almost there. We're like right in the 190s. I'm just going to try to get it up to 200 just so I know for sure that the balls have fused. Looks like inside the nozzle we're at like 219. So we should be good. Let's see, 191. I just, on the outside of the board, I just want to make sure that we are close enough to that 183 target. And I'm seeing 193 now. So I think we're good to go. And now we're at 195. And inside our hotspot is 224. My thermal camera is starting to get hot, so I just want to back it up just a little bit. All right. So yeah, I think we're good. Just go in one more time. Yeah, I think we're good. So, all right, so we're going to shut it down. I'm going to turn the air down. I'm going to turn my temperature down. Let's go back to this. Take my hot air station, and I'm going to turn that down. All right. I shut my air off, so hot air is shut off now. And I'm going to go ahead and very carefully try to lift my hot air iron. So give me 1 second here. I'm just going to move the microphone out of the way to make it a little bit easier because I don't want to touch the socket. So. All right, so the hot air gun is out of the way. I have my hot plate. I'm gonna turn it off right now. Okay, so hot plate's off, and basically what we got to do now is just play the waiting game. I'm gonna let the board cool down. I'll pause the video, and then I'll get back to you guys as soon as the board's cool. So I'll see you guys here in just a second. All right, guys. So, yeah. After we left off with the heater there, I let the board cool down. I messed around with the socket a little bit, and it popped right off. It didn't solder. So, just to let you know, it is going to take a lot more heat. I then put the board back on, heated it up a lot more, got it up to like 250 degrees, and melted this whole top piece here. It got really melted, and the socket was kind of warped a little bit. If I were to do this over again, I would probably try to figure out a way to put the board in the vise to keep it from curling. That's what this was for, this back plate here. I took the plastic off, and that's why I had the washers to keep this socket as straight as possible. But anyway, and this one side was coming up here. I didn't like the way that it was coming up. The rest of the socket seemed like it was soldered on good, so I put it back on a third time and heated it up again more, and finally it seems like it is on there as good as it's gonna get. So unfortunately it's a little anticlimactic. We can't really test it, but at the very least we can put it back together, and then as soon as I get a CPU, we're going to test it. For whatever reason, if this doesn't work, then I will go ahead and figure out like a clamping system to keep the board straight, and then we'll just go ahead and do it over again. And worst case scenario, so either, you know, I'll try to reflow this socket first, and then if the reflow doesn't work out, then I will use my spare socket here. So now you notice this one's missing the cover. That's because I just used it here because this one got melted. Yeah, you can see. So probably best not to leave this on when you're reflowing the socket. It's probably best to take this off, so that way the heat can contact the pins and put the heat into the solder balls. But yeah, I mean, it's on here solid. I checked all the sides. It seems just about as solid as it's going to get. I mean, I'm looking at it. It looks like the left side might be sitting off the board just a tad. Yeah, that side's good. That side seems like it could probably be seated a little bit better, but the thing is, let me see if I can pop this off real quick. The pins, I don't think the pins are actually moving. I think it's just the plastic casing that's moving. Yeah, I think it's just the plastic casing. It seems like the pins are pretty well soldered on there. So I'm gonna go ahead and just call it a win. I think it's pretty good. It looks good to me. So so let's go ahead and I'm just gonna skip through this real quick, make it quick for you guys, and we're gonna go ahead and throw this back together. So we're just gonna start by putting the back plate on. Oops. There we go. All right, so we're gonna start by putting the back plate on, and I'm just gonna pause through this as we go along, just to show you guys real quick. So this is all the stuff that I pulled from the motherboard, and we're gonna go ahead and slap it back together. All right, so we're gonna start with our carrier. The handle always goes towards the memory, so make sure that whenever you do that, it's always facing towards the memory. And then I got my screwdriver here, and we're just gonna go ahead and screw it down. Also, if for whatever reason some of the pins didn't solder the greatest, in that when I reflowed this new socket on, there is a chance that whenever you pop the CPU in, that the sheer pressure of the heatsink on the CPU pushing down on it and pushing down on the pins will make contact with the pads on the board. And if they're clean enough, you shouldn't have any issues, but who knows, you know, you never know. So but anyway, that's on nice and tight, and let's get to the VRMs and the rest of it. All right, I'm going to start with the PCH here. Now, the PCH is that little teeny chip. It's like your Northbridge chip. You want to make sure that you are always extremely careful whenever you go to put the heatsink on, because you could cause damage like super easily, because the bare die is visible. So, you know, if you hit it wrong, you could crack the side of the die, and you definitely don't want to crack that. All right, so our socket's in, PCH heatsinks in. We'll go ahead and put our battery back in. And if you saw the last video, there's this little plastic tab here that keeps the battery locked in. I'm just going to put that in just for for completeness sake. I just want to make sure that everything is exactly where it was before. And next we'll go ahead and put our Wi-Fi card in. I put the screws in, so I just need to take these screws back out before I mount the card. It's pretty cool how there's like that little tiny, it's like that little M.2 socket there. I wonder if I could put a drive in there and see what would happen. I'm really interested. Maybe I might try that one day. I'll try to put like a little M.2 there and see what happens. Or a little SSD, whatever the key is. I know it's more than just for Wi-Fi cards. You can put other stuff in there too, but I'm very curious to see if you could just like throw a drive in there or something, or like a little mini capture card and just have it like sticking out of the back of your computer. All right, so now that our Wi-Fi card is installed, we can go ahead and reinstall the it's like an all-in-one, so it's the back plate and the heatsink. There are two screws on the back, so we could separate these two, but that's the way it came out, so that's the way I'm going to try to put it back in. And I think, yeah. Boom, bingo, there we go, perfect. So I'm just going to lean it back carefully, and I'm going to find my screws here. I got a couple screws. I think it's these two. Yeah, all right. So let's go ahead and screw these in. All right, starting to look like a motherboard. Now we need to do the top VRMs here. It's a pretty nice motherboard. It's got a lot of power stages. I don't know if they're doubled up, like if they're in parallel, you know, 2, 2, 2, 2. But I mean, it's still, even if they are, that's still a lot of phases. Because you always hear like motherboards, they say like, oh, true 16 phase. That means that every single phase, power phase is independent. But whenever you have the phases doubled up, which I don't think this board uses doubled up phases, because you would see one chip every 2 MOSFETs. So there'd be like a tiny little chip here, 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 here. And what that does is that duplicates the signal to each pair of MOSFETs. So they both put out the same power. Cheaper boards do that, but more expensive boards have a more expensive controller, and so each MOSFET gets its own signal. All right, and there we are. Everything's on. We got all our M.2 little standoffs on the board. We got our PCH heatsink on the board, nice and tight. Hopefully not too tight. We got our main heatsink and our back plate. And we also have our secondary VRM headset, VRM heatsink, and our cover for our socket. Socket's in, nice and clean, looks good. So yeah, let's take a quick look over the board and just take a look at it real quick, and then I'll sign out. We'll look at all the features and stuff real quick. All right, so the MSI MAG B650 Tomahawk Wi-Fi. So it's got a decent amount of features. I mean, you got HDMI DVI. Oh, right. Yeah, HDMI DVI. You got 2.5 gigabit NIC. You have 2 super speed USB 3s at 10 gig. You have a 20 gig Type C. You have a flash BIOS utility too on that USB, and you just push the button there to flash BIOS. Then it looks like we have 2 regular USB. It says USB plus, so I don't know if that's USB 3.0 plus, those 2 black ones. And then we have USB 3.0 right there, super speed. So maybe that's what, I don't know. Anyway, I'm not going to talk about it right now, but maybe that's what they were talking about with my other motherboard, because it kept saying, my VR headset kept saying, you don't have a USB 3.0 plus. And this has a little plus on it. So and then we have our audio. We have a SPDIF optical out, which is pretty nice for a board like this. No reinforcement on the back. Everything's exposed on the back, so you do have to be careful. And before I put this in a computer, I will just double check, or before I test it, I'm just going to double check and make sure I didn't knock off any components, because it did kind of slide around on the jig a little bit. Yeah, if we take a look at the top side, we have our built-in Wi-Fi, and then on top of our built-in Wi-Fi, we have a PCIe 16 reinforced. So this is reinforced for your graphics card, you know, with the SAG and whatnot. Then we have a normal, this is not a by 16, this is a by 4, but in a X16 slot, which is pretty interesting. Yeah, I'm pretty sure that's a by 4. It might be a by 8, but I'm pretty sure it's a by 4. So we have a PCIe by 4 in a PCIe 16 slot, and then we have a PCIe by 1 right here. We have our 3 M.2 slots. Obviously it didn't come with the heatsinks. I wish it did, but yeah, so we have our 3 M.2s here. We have a USB 3.2 on the board. We have our diagnostic LEDs. We have our USB 3.0 header there. We have our SATA. We have a bunch of fan headers all over the place. There's RGB header up top. We have an ARGB header right next to it. Then we have another ARGB header on the bottom. We have our terminal block for our power button reset, all that stuff. We have a bunch of fans, USB. I'm not sure what some of these are. I don't know if like maybe it's a JBOD or something. But yeah, there's another one. So we have another RGB header here. So we have 2 of the older RGB headers and 2 ARGB headers. And if you don't know what RGB versus ARGB is, so RGB is just analog, it just on or off. The ARGB is, the A stands for assignable, so it's assignable RGB, so it has data that goes through and talks to every single LED in the chain. Yeah, it looks like it has decent capacitors. There's only one BIOS. It's not, so I noticed it's not dual BIOS. This is the BIOS chip right here, so you can see there's only one BIOS. And yeah, here, I'll just take a look underneath the microscope real quick. So yeah, so there is our BIOS chip. I think this might be JBOD. I don't know, TPM. Oh no, TPM I think is to read the I don't know, TPM I think is to read the bridge chip or whatever it is. This I forget, I was just talking about it earlier. But yeah, so we got a couple crystals by the CPU, and you're not going to be able to tell because the retainer's over top of it, but all the flux is cleaned off, and you can see it looks like it's lined up pretty well with the socket here. So let's just open this up real quick. Open it up and then just gently remove our socket holder. So you can just make out the PCB underneath this section right here where there's those cutouts, and you can see like there's a hole there in the corner. You can see just a little bit of flux, so you see how the board is shiny. But yeah, we can kind of see through the socket here just a little bit. And yeah, I mean, I'm pushing on the plastic here. You can see it's not really moving at all. The pins definitely aren't moving. But then if we come up here to the top, yeah, that's not really moving either. Let's check this side here, because I know this side was kind of moving a little bit. Yeah, see, this side's moving, but you don't see, it doesn't look like the pins are moving. It looks like it's just the plastic frame that's moving. So we'll see, but yeah, I mean, it looks good. All the pins are nice and perfect. Obviously, we don't want to mess up this socket. And here, so there's a better look so you can see. Yeah, so there is our pin socket. Looks nice and brand new. So yeah, I don't know, just give me like 2 weeks and I will eventually update you guys with how everything went. Holy crap, that is hard to close. Is that even in properly? Yeah, I guess it is. But yeah, so just stick around with me and I will update you guys on whether or not the replacement worked of the socket. And if you guys want to try this yourselves, go ahead. If you have any questions, just leave me a comment down in the comment section and I will do my best to try to help you guys if you decide to take this on yourself. Obviously, I gave you all the information you could possibly need. Only thing I would advise you to do is make sure you remove this. Low air, don't crank your air up all the way. And also, when you're pumping heat into it, try to get to maybe like 240, 250, somewhere around there. Maybe 250 is too high. But at least try to get it up to 240, like near the socket, so you know that it's like melting adequately. And another thing too would be just to try to put it in a jig, so that way the board doesn't doesn't bow. Because whenever you heat these boards up like this, they do flex. They flex all kinds of ways. You have all these like solder connections all over the place, and you can see here, like, well, you can't really see it, but the board is kind of bowed up a little bit. It doesn't really look like it's bent too much, but it does look like it might be a little cockeyed there. And you want to avoid that. Now we can get rid of this, but what we would have to do is we'd have to put this in a vise and then heat it up in the vise and then let it cool down in the vise. And once it cools down, it'll maintain its flat shape, but should be okay. Like I said, that's what the bracket was for, with the washers all around it. That was to keep this area as flush as possible, so that way the socket's not at an angle, and when it solders, that way it drops down evenly. So anyway, catch you guys later. Hope you enjoyed the video, and yeah, have a good one. Peace.